Right, we're in algebra. What the activity you just did was solving an equation. I'm just going to recap a little bit quickly before we get on to this. This is what we want. We want to be able to do the inverse of a function. Now, it's actually nothing much different to what you were just doing, which is why I gave it to you to do. It's just got a different name and a potentially different purpose. Right, so let's just have a. Let's first have a look at a little bit of vocabulary. What is an expression? An algebraic expression. Give me an example. Well, an expression has terms in it, right? So, okay, 11a on its own is an expression with one term. Yeah? You would call that a monomial of degree 1. Good. Give me an example of a binomial expression.
Something with a degree of 2.
Give me an example.
Oh, can I think?
Would you like to go?
11a plus
Should we do by B plus
4c.
4c? Good. That is a binomial of degree.
What?
3b squared plus 2c is a binomial of degree 2. Remember, the degree is the highest power in the term, not how many terms there are. What would a trinomial of degree 4 look like? That.
You could do like 7 4 plus 7 subtract 1.
Yep, that's a trinomial with a degree of 4.
Still, but you said we were gonna have math homework over the break, but I never saw any of that. Did he say it was only for you? Like I remember him saying.
I forgot in the first week, and then in the second week, I thought, we're on with it. But while we're talking, shall I pause? So we have monomial expression, binomial, trinomial, another binomial, a trinomial. They are expressions. What are equations?
Like 11a plus 5 power of 2 subtract 3b to the power of 3 divided by 4 c.
I think you're going too far along. I'm just going to start with just 11a, because the thing that makes an equation you didn't add.
I said
What?
11a.
Ah.
It's still there.
You've given me an expression. I want the expression turned into an equation. That's a simplification, right? You simplify by collecting like terms. An equation is different to an expression because of what you've just been doing, which is 11a equals 22 is an equation. What? So yeah, that's the difference between an equation and an expression. So an equation is an expression that has a value. And what you immediately did was, well, the equation with a value, I can now work out what A is, right? Why can't I tell you what A is in the expression?
Solve for it. Also, we don't know what it is.
Yeah, 11a is simply an expression of what you want to do today. What 11a is? What You don't know what A is. A could be anything. But if I turn my expression into an equation by giving it a value, now we can work out what A is. That's the difference, right? So, for instance, like you've just been doing, 3x plus 2 equals, should we say, 20. That is an example of an equation. An equation on the computer screen that you just did, should we say 4t's plus 3 equals 2t's plus 11 is an equation. Okay? All right. So a bit of vocabulary now. Substituting into an expression gives it a value. E.g., 11a, if a equals 4, then 11a equals what? 44. Because we replaced the a, so we've got 11 times a, but 11 times 4 equals 44. So we've done this as well. We've done, when you substitute in, so for instance, another example, 3x plus 2, when x equals minus 2. Well, what would 3x plus 2 equal in that case? It would be 3 times minus 2 plus 2, which equals example. Because I think it's in Latin or something like that. I.e., e.g., I don't know. You can ask your English teacher. Why does e.g. stand for example? No, because it's not English. I know it. It might be e something g. Like I.e. is I something e is not a word that begins with e. I should know, but I don't. What is Mackenzie very, very skillfully took us away from what we should have been thinking about. Now she's going to tell me the answer. 3 times negative 2 is? 3 times, if x is negative 2, 3 times negative 2 is? Negative 6. Negative 6 plus 2 is? Negative. Oh, I thought that was you. Alright, guys. So, guys. An expression just tells you what to do. An equation is an expression with a value. Substituting into an expression gives it a value. Okay? Which leads me to the final thing, just for now. Solving an equation finds the value, I will write something. Finds the number that was substituted into the expression. So that's basically what you've just been doing on the computer. Does that make sense to you, what I've just said there? So solving an equation means finding the number that was substituted in the expression. So, for instance, if I go for that one that was on your computer screen, I believe it was 4t's plus 3 equals 2t's plus 11, all right? We want to figure out what t has to be, yeah, to make that true. Remember I said the equal sign needs to still be true all the time? So over to you, how would we solve that? We did a lot of this before the break. How do we solve that? Think of the scales approach. It's not the easiest one we've done. We've just been doing it. T stands for tomato. There was 4 tomatoes on one side. Remember we used our scales. Alright, here's the set of scales. We've got 1, 2, 3, 4 tomatoes, a weight which was 3. On here we've got 2 tomatoes and a bigger weight that is 11. So how do we solve it? Solving is to figure out what does t have to be to make it true. What do we do? First step. Take away 2 t's. So I'm going to write 4 t's take away 2 t's plus 3 is equal to 2 t's take away 2 t's plus 11. And that leaves me with 2 t's plus 3 equals 11. Next step. Yeah, your hand up. Do you want to do the step? Oh, I want the steps. You can tell me the answer but not tell me the steps. Tell me the next step then. Take away 3, yeah. 2 t's plus 3, let's subtract that 3. And 11 minus 3 on the other side leaves me with 2 t's equals 8. So what we've just done is took away 2 t's from both sides, 2 tomatoes. We took away the 3 there, but obviously I have to take away 3 from the 11, which makes 8. And then we share the 8 between the 2 t's, so dividing by 2 gives me 1 t is equal to 4. Okay. That is solving. You've done plenty of it, right? All good? That's like kind of the highest level of solve. Well, not quite, but having unknowns on both sides is quite tricky. Right, what if I gave you the, let's solve this one. A simpler one. 3x plus 2 equals 20. Solve that, showing every step. 3x is plus 2, take away the 2 equals 20, take away the 2. That leaves me with 3x is equals 18. So that's like taking that away and leaving only 18 on that side. And then you divide it by 3, both sides, and you get x must equal 6. How do we check that I'm correct, by the way? That was good in math.
So basically, what you do, you, oh yeah, I forgot.
You check by substitution. Right? So if we think x has to be 6, what we do is we go, oh, does 3 times 6 plus 2 equal 20? Am I correct or not? Well, 3 times 6 is 18, 18 plus 2 does equal 20. Yes, I'm happy I've got it correct. Sometimes you can do that and end up with a number that doesn't work. For instance, someone in the room was doing the earlier one and got the answer 3.5. The maths was correct, but they just didn't subtract 3 from 11 very well. Now, if I'd put that answer back in, I'd have realised I did something wrong. Yeah. Okay, written that down? Is that reminding you of stuff that we've done? Yeah? Probably the most mathsy stuff that we've done, like just pure maths. Difficult to apply it to things at the moment, but it's just maths, isn't it? So some of you are going, oh my God. Right, let's go back. So this, by the way, this is all you need for the next thing. All right? So, find an inverse function. Do you remember what a function machine is?
Something in it.
Yeah, good. So we've got y, I'm going to do this first one with you. Y equals 2x minus 10. If I write that as a function machine, what variable goes in? X. And what gets done to x?
Get subtracted from 10.
What first? What's the first thing that happens? Gets multiplied by? So it's like, what do we do when we substitute in? So you see everything in algebra is substitute or solve. There's nothing else. What do we do when we substitute? Sometimes there's simplifying, but that's just simplifying. We just need to substitute or solve. So what happens to x when we substitute? We times it by 2, we get an answer, and what do we do with that answer? We have to
So just subtract it.
subtract 10 from it. And what do we get out? The answer. What's the answer? In this, there's no negative part. No. What can x be? Anything. What if I put 3 in? What do I get out? 3 times 2 is 6. 6 subtract 10 is negative 2. What if I put 8 in? 8 times 2 is 16. 16 minus 10 is 6. Do you understand how a function machine works? Yeah? What's x? Whatever you decide it's going to be. What comes out? What do I call this?
Filter?
Y.
Oh, because
Y equals. Y is the answer to 2x minus 10. That's how we read it. That's why I said algebra is all about the language of it.
stuff out.
Got that? Right. Any ideas what you think the inverse function that is?
Like they want you to like do it in reverse.
Yes. Have we already been doing something in reverse? We were solving, weren't we? That's substituting. Solving is going backwards to what we put in to start with. So, this is the function. What do you think the inverse function would be? We start with something. What is the inverse? Do you think? What do we do to go back the other way? Nope. So we could start with y. What do we put in the box? What is the inverse of subtracting 10?
What adding 10?
Adding 10. And the inverse of dividing by 2 is dividing by 2. What comes out? X should come out. How do I write that as an inverse function? Well, what I do is I write this. I say it's y plus 10. All of that gets divided by 2. And that equals x. That is what you would do if you were going to solve it. So let's just check. Let's put negative 4 in. We should get the answer 3. Negative 4 plus 10 is positive 6. 6 divided by 2 is 3. So it does the opposite. It does the inverse. Okay? Now, there is one final. Okay? So let's do this. Let's write this first. The inverse function is the inverse of each operation in the inverse order. Inverse means, you've already told me once, opposite. Yeah? The opposite of in maths. We right?
My head's tired.